Welcome to the House of Maths, and today I'm going to be looking at the sine rule and in particular the ambiguous case. Now this is the typical setup for the ambiguous case. We've got what I'm going to call AB, let's say that's the ground, and we've got a 15-metre length going from A up here to C, and it's inclined at an angle of 25 degrees. And what we're asked to do is, we're told that we've got a 10-metre length and it's to be connected from C to the ground. AB to complete a triangle. So we've got to put this 10-metre length from C to the ground to make a triangle. Now, if you're thinking that you can just put it straight there like that to make a right angle triangle, that's not the right way to go about it, because this length here, I call it X, it is less than 10 meters. Okay, so you can't just drop a perpendicular down like that. It's got to be 10 meters long, so that's not going to work. So what happens here is the 10-meter length is going to have to go somewhere over there like that. That will make it 10 meters. But you might also spot that it could go this way. And that would also be 10 meters. So we're not sure which way it's got to go, hence the ambiguous case. That's why it's called that. So how do we know which line to put in? Well, that's going to depend on the way the question is phrased to you. So what usually happens is you're then told, it would say find the, just going to put a little gap there, angle between the 10-meter length and the ground. Okay, so that's what we've got to do. Now, why have I left this blank here? Okay, well, if you look at our triangle that we've created in this direction, the angle between the line and the ground is going to be this angle here, which I'll call X for now. But if we go the other way, if we were to put that line in, we'd be creating an angle here, which I'm going to call Y. Now, you probably will notice that those angles are different. So this angle here is an acute angle. Remember, an acute angle is an angle that's less than 90 degrees. And this angle here, angle Y, is an obtuse angle. So that's an angle that's greater than 90 degrees and less than 180. So what you would be asked in the question is probably the one they would ask is to find the obtuse angle between the 10-meter length and the ground. So they're going to be asking you to find angle Y. Okay, and you can do this, you can find the angle by using the sine rule, because you've got an angle and a length opposite it, which would be this one or this one over here, and then you've got an angle that you're after and you've got the side opposite over here. So we can use the sine rule to work this out. Now, if we're looking for angles, we want the angles at the top. So we're going to use the sine rule like this. Like so. So let's put in the information we've got. So I'm going to call this one sine A. So we've got sine 25 over 10 equals sine Y over 15. Now, if we multiply through by 15, we're going to get sine y equals 15 sine 25 over 10, and then we can work this out. A calculator. So I'm going to do that now. So we've got 15 okay, that gives us the sine, and all I'm going to do is convert that into an angle by using shift sine. I'm going to put that in there, and that's going to give me 39.3 degrees. Okay, so y equals like so. Now, as you look at that, you're probably thinking to yourselves, hang on a minute, we're after the obtuse angle, and we've got 39.3. That can't be right, can it? Well, what happens with the sine rule is it is going to give you the acute angle. Okay, that's what you're going to get when you use the sine rule. So in order to get the obtuse angle, you've got to do another little calculation. Now you might notice that this setup here, where I've put the 10 meters here and the 10 meters here, they're the same length, aren't they? So this triangle shape that we've created, yeah, this is an isosceles triangle we have there. So one of the features of an isosceles triangle, which you should know, apart from these sides being the same, is that the angles, I'll put them in a different colour, the base angles are going to be the same. Okay, so in order to find the obtuse angle here, we've got angles on a straight line, so y is going to be 180 minus 39.3. So that is going to give you y equals 140.7. So you can use that feature of an isosceles triangle to get this answer here. So that's how you use the sine rule to find the obtuse angle. And they do, as I say, they do tend to ask you for the obtuse angle, because using the sine rule is just going to give you the acute angle. So you've got to know how to go from the acute angle to the obtuse angle. Now, that's the quickest way to do it. You might also want to know of another way. If you can't remember the sine rule, there is another way you could do this. So if I just go back, I'm not going to work it all out, but I'll show you. So what you could do is you could drop a perpendicular there to create a right angle triangle. Now you've got an angle here and a side here, so you could use SOHCAHTOA to work out that length, and if you did that you would get roughly 6.33. Then you could put the 10 meters in over here, and now you can see you've got a side, and you've got a side, you've got two sides in effect, haven't you? So you could use that to find that angle over here if you wanted to. You could use SOHCAHTOA to do that, and then when you've got that angle, you can use the same idea that we did before, angles on a straight line equal 180, to find that side, to find that angle just here. So you, as I say, you could use SOHCAHTOA to do it as well. It just means you've got to do a few more calculations on the way, but you would get there eventually. Okay, so that's the sine rule, the ambiguous case. If you enjoyed that, please remember to hit the like button and subscribe. Thank you very much.